The thermohaline circulation refers to ocean circulations that are driven by density variations due to heat, that's the thermo part of the word, and salt, that's the haline. Cold water is denser than warm water, and salty water is denser than fresh water. And together, these variations can drive large changes in the density, which can cause water to rise or to sink.
The thermohaline circulation is an ocean circulation that connects all the world ocean basins together, and that has important impact for climate because it acts as a thermic regulator of the Earth. So a lot of excess heat is received by Earth in the tropics compared to the poles, and this large-scale circulation allows to distribute the heat over the Earth.
The thermohaline circulation is important because through these currents, it transports heat and salt. And in the case of the Northern Atlantic, the thermohaline circulation brings warmer temperatures to the North Atlantic. The thermohaline circulation is also important because the deep water formation will store carbon and bring carbon from the atmosphere into the deeper ocean layers. And it's also important for sea level. The thermohaline circulation, due to the structure of the currents, it results in the Atlantic being about a meter lower than at an equivalent latitude in the North Pacific. Finally, the thermohaline circulation is also important to the biology of the Atlantic system. Climate change projections suggest that there will be a weakening of the thermohaline circulation over the coming century. This is due to both the temperature and salinity-driven components. Surface temperatures are projected to warm, and this will decrease the density of surface waters, leading to reduced deep water formation. Many models project a decrease in salinity due to increased runoff from the Greenland ice sheet. Our research on salinity have shown that there has been a decrease in salinity in the subpolar North Atlantic since the year 1900. Whether this is enough to have affected the thermohaline circulation remains to be seen.
From observation, it's still hard to know if there is a decline. There is no clear sign of a decline. There is a consensus that the thermohaline circulation will decline in the future in the North Atlantic.
A weakening of the thermohaline circulation would have strong regional climate changes. Now, in the case of a decrease in the thermohaline circulation, this would be projected to cause a disruption in the monsoon system in the Sahel, in North Africa, and also potentially in tropical South America. These linked changes have been seen in historical thermohaline variations. Now, within the context of global warming, there's projected to be regional cooling in the subpolar North Atlantic, and this would potentially cause cooling within Europe in a situation of thermohaline slowdown. There would more broadly be cooling in the northern hemisphere with increased warming in the southern hemisphere. And this interhemispheric pattern is a signature of slowdown of the thermohaline circulation.